I don't know if you can see this.
What?
Oh my God.
This is a natural process. This is a supernatural process, right?
The algorithm kept us on the platform. Therefore, it was a good algorithm. But should we have stayed on the platform?
I think to be human is to recognize that you're alive. Human health and our sustainability as a species on Earth is only as secure as our global plant populations.
This is Built Human. I'm Andrew. This is John. We're joined by Alex Grant. The world keeps moving faster and faster, but somehow our health and our humanity get left behind. We're working out in real time, questioning everything, amplifying what works. Alex, so happy to have you on the podcast today. Well, this is a special one too, John. You kick it off, but we go very, very far back in time with Alex.
Yeah, today we're really excited to welcome Alex Grant, COO of Foray Bioscience. And as Andrew mentioned, we go back a really, really long ways, over a decade. Alex is a former president and resident of eTower, Babson's prestigious entrepreneurship community. So he's been working with startups and working with people and mission-driven entrepreneurship for a long, long time now. That's where Andrew and myself met him a long time ago. He's been a close friend and mentor for both of us as he's expanded to this new role at Foray. He spent, I think, 4 years, Alex, you can correct me, at the Engine in Cambridge. And funny enough, he's also an Iron Man. So we like to focus on a lot of things here at Built Human, between the business aspect, the startup aspect, but also the mental, physical, and well-being aspect of that as well. So Alex, welcome. We're glad to have you.
Yeah, thanks for having me, guys. Excited to be one of the first few guests on the show.
Amazing. Yeah, it's an honor, and we always ask really one prepared question, and then the podcast devolves into what it will be. And that is, what does it mean to you to be human?
I think to be human is to recognize that you're alive. And I know that that sounds a little foo-foo, but we often get caught up in the things we're supposed to be doing in our day-to-day lives. And sometimes it's nice to step back and, figure out why we're here. That question has led me to the work that we do today, or that I've done throughout my career thus far, and especially now with Foray. If all else ended tomorrow, what would be left behind?
That's
I love that.
Incredibly deep. Yeah, I want to dig on that, but I think it would be a good time to let you expand a little bit on what you do with Foray, because it's so important and, as you just said, so related to even the fundamental premise of our show, in a sense.
Yeah, I mean, so at Foray, we grow plant products from the cell up. And you might be familiar with lab-grown meat. This is essentially what we do in the plant world. The benefit of plants is that they have this natural regenerative capability, just as you would, propagate a plant in your garden. Plants have the internal blueprint to be able to grow any part of the plant. And so we're simply directing that that plant to become specifically the part of the plant that we want, so that we don't have to harvest these things from the top down. We can build them from the cell up.
Yeah, the example that kind of stuck with me when you were first introducing me was like growing wood.
Yeah.
Because it's almost like, think of all the, I guess, deforestation that has to happen to keep up with the amount of wood production just to live in our societies. Yeah. And I was looking around the house and thinking, well, what if this house was just grown from a cell? And that was a very profound thought when you introduced that to me.
Yeah. I mean, it's interesting. Plants play just an outsized role in our day-to-day lives. When the average person hears plants, they think, oh, that sustainability thing. But plants, underpin about half of the global economy. It's about $44 trillion by some measurements. That's probably the biggest industry on Earth. And humans have had a relationship with plants for as long as human history has been recorded, and even before. And so I've been saying this, and I hope you all agree with this. Human health and our sustainability as a species on Earth is only as secure as our global plant populations. And so that's the goal of the company. How can we change this demand equation? If we're going to continue to demand more from plants, how can we help support those systems?
I was going to say, tell me more about the human health connection. I think that's an important one. We talk about human health a decent amount on this show, but I'm curious to hear more from that from a demand perspective as one of the largest industries.
Yeah, I mean, there's two levels to this, which is the floorboards you walk on in the morning, the house that you're sitting in right now, the food we eat, the fuels that more than 30% of the globe burns, um, the air that we breathe. These are all plant derived, whether we know it or not. And so when we talk about human health, it's just your human well-being every day is supported by plants. The second layer is when you think about the role that plants play in biopharma and food, they obviously have a direct role in our overall health as humans. And so I like to think about, as I mentioned before, we have to first secure these global plant populations, and then we need to figure out what blueprints are going to best serve human flourishing in the future.
I was going to say, I think the thing that we often miss too, obviously it's a part of our diet, part of our home, etc. But like, there's also an emerging trend too. It's part of replacing all of these pharma chemicals in our life that we clean and exist around. I think like I've made a conscious effort to eliminate a lot of the chemicals in my shampoos and my deodorants and my body washes as well. And plants are becoming more of a focus within helping us live cleanly as well. So it hits home that there's a market that expands, and it's not, well, I mean, it's a renewable resource, right? But in the effect of how quickly human populations are growing, there's a supply and demand issue
Yeah.
that becomes very hard.
Yeah, certainly our demand outpaces the ability for plants to regenerate. And so it sort of begs the question, which side of the equation are you supporting? Are you growing things from the cell up so you don't have to harvest things from nature, or are you enhancing a plant's ability to regenerate so that you can continue to harvest? In either way, you need technology to support that system.
Yeah, that type of material science can't be easy. That's incredible. I mean, what's the story there? Like, how long did it take, and how much R&D goes into being able to do this?
Well, I think the story really starts at MIT. Back in 2018, 2019, our founder and CEO, Ashley Beckwith, spent her PhD inventing lab-grown wood, lab-grown lumber. And so this idea that you can assemble wood and its material properties from the cell up. And the company was founded in 2022 with the idea of how do we translate the knowledge of having created wood in the lab to not only wood, but other products as well. And so each product, I mean, I mentioned that it tackles such a large swath of the global economy. It would be insane for any one company to start with every possible plant-derived product. And so the way we think about it is there's a series of innovations required over time to grow anything from the cell up. This isn't a new technology, cell and tissue culture. This is about an 80-year-old technology that is now entering the age of AI and ML, right? And so how do you manufacture the conditions that those plant cells need to succeed is the biggest blocker for R&D today. We have successfully built a few products. The one that we're very excited about right now is called fabricated seed, which we can get into. But this is a lab-grown plant embryo that can be sown in the ground like a natural derived seed. And that's been years in the making.
Yeah, that's incredible. And I think it's one of those things too where people talk about bipartisan issues, and I would say we've had people on the show, and we have our health and wellness brand that focuses on maybe more like an animal based type of diet, but the lifestyle that's underpinning that and the people who follow that, it's a bipartisan issue with the other communities who only eat plant-based, or people who frankly are into health and wellness at all. I think the one thing that underpins all of them is this idea of well-being that relates to the planet. Like you said, it's like get outdoors, get sun, enjoy nature. The microbiome changes from just breathing the air differently in nature with plants is so much different than being indoors, shut inside. And I think what you're facilitating by increasing supply so that we can just preserve natural beauty, I think that's just, if you open your eyes and look at the world and you mean well, I don't know how you don't support that. So I think it's
Yeah.
a beautiful thing, and it should just be something that people appreciate the mission, at least,
Yeah.
I think.
I mean, what's the saying? The political parties are two wings of the same bird, right? Um,
Yeah.
I think that's a apt, natural analogy for sort of the work that we're doing. You don't have to be a Democrat or you don't have to be a Republican to care about your, community and care about nature, and both appreciating it from a beautification perspective and being able to be recreational, be outdoors, connect with yourself and other species, but you know, also for caring about your neighbor and caring about the health of your community. These are
Mhm.
these are things that are nonpartisan.
And so, talk to me a little bit about the founding thesis. You brought up Ashley, whose thesis was centered around the construction of wood cells for a more firm replication product, right?
Mm-hmm.
Like, tease that out a little bit more for us, as far as what the problem was that derived the early standing solution.
Yeah, I mean, it really goes back to this macro issue, right? What are the plant products that we use the most in our day-to-day lives, and what are the systems, whether that's agricultural or biotechnical, that support those systems? And in the
Mhm.
case of lumber, these are trees that take many, many decades to grow. And when you cut them down, you process them and then you restart that, decades long cycle again. And in the process, you are optimizing for a very specific genetic trait of a tree. Maybe it's the durability of the trunk, or in the case of paper and packaging, maybe it's the lignin quality, or the quantity. Sorry. Um, and so, both from a control of the parameters and the qualities of that plant material, and from sort of a more sustainable production system perspective, growing things from the cell up is a better path, we believe. Um, I actually have a surprise for you guys. Um, I have brought some samples along with me about what it looks like when we first are starting out working with plant cells in the lab. So I don't know if you can see
This
this.
is awesome.
Um,
What?
Oh my God.
so these these are called callus cultures. These are clusters of plant. Uh, I guess it's the equivalent of a plant stem cell. So just in humans, where they're undifferentiated cells, um, these are these are clusters of undifferentiated plant cells. And what we do is we direct those cells to become other things by exposing them to various environmental factors and plant food. And so this is an example of where we've directed. Let's see if we can get a good picture here. Yeah. We've directed those plant
Wow.
cells to become embryos. You see those small little white dots coming off the side of these brown clusters.
Mm-hmm.
Yeah.
Um, these are embryos. But you could just as
Incredible.
easily direct those plants to become fibers for paper and packaging, or you can start to create the precursor to wood. And um, in this case, we've directed them to become fabricated seed. So these are actual
That's incredible.
fabricated seeds. You can see the embryo on the
Wow.
inside. It's encapsulated in
Wow.
a hydrogel.
This is super interesting. And so at this point in time, you said you can direct them to be wood or a number of things. Does the plant, this is kind of I guess an odd question, but does the plant have an identity at that point in time when you have it just the cell? Like what, or are you capable of directing it for any use case and growing it swiftly?
Yeah, I mean, in concept, you can direct those undifferentiated cells to become any part of the plant again. In fact,
Wow.
there are some people that will do genetic engineering at the cellular level to produce even molecules that a plant wouldn't naturally produce. So there are people that are trying to create chemotherapy drugs within the context of, cells and root fibers.
Mhm.
But today we're focused primarily on building material systems. So whether it's the fiber itself or um, growing full plants again, which I can show you the full plants too. So
I love this show and
yeah,
tell.
these are actually red spruce trees grown from the cell up. And you can start to see they have their
Wow.
prickly needle-like leaves starting to form. And so even here you can
Wow.
start to see what the real properties of the full plant looks like.
What are they hanging around in there? What's
I call this artificial dirt, but this isn't the real technical term. This is called media. Media is essentially plant food in its specific chemical and hormonal balance that's needed to direct the plants to this particular outcome.
And so how long does the growth process take? I mean, that's obviously a red spruce tree at scale,
Yeah.
right? Like not to scale. So how long does it take to become a true spruce? Does it follow a typical developmental pattern, or are you engineering that to be a much quicker timeline?
We're working with natural biologies here. So these are samples that we've gotten from nature, from real ecosystems. And so in concept here, now that the plants have germinated, when you transfer them to soil, they'll grow at the same rate that a tree would in its natural ecosystem. Of course, there are ways to hypercharge that or speed it up, but um,
Yeah.
our intent is to grow them like a typical plant.
So like
Amazing.
when you're increasing the supply, and we're talking maybe lumber or fibrous packaging, materials that are in demand but we can't meet, you're kicking the process off and then you're letting nature take its course, and you're actually just planting them in environments, or like what are those things you could do to speed up the
Yeah.
process of getting those in time, I suppose.
Well, in the case of wood or fibers, the fastest way would be to sort of shortcut the full plant growth altogether. So instead of going from, this cluster of cells to an embryo to a seed and then a full plant again, you could go from this cluster of cells to fibers. And so instead of having to grow the full plant again, which might be a decades long process to maturity, and then you have to process it, um, you're going from this structure to the desired end structure directly.
That's incredible.
Yeah, but what's cool about this fabricated seed process is that if you can go from biopsy of the plant to callus culture to embryo to full plant again, you've completed the life cycle of a plant. Um, you've demonstrated that you can grow the full plant from the cell up. You've learned a lot along the way as to what food is necessary in each stage of development, and so it's an iterative improvement on that process to be able to go from callus to some other direct product.
How have you seen that change the outcome?
You mean going from the cell up as opposed to the top down generally?
Yeah, like I'm particularly curious about the, I guess, final product in this
Yeah,
instance too, right? And how closely mirrored it is to real uh, natural processes, right?
yeah. I mean, this is a natural process. This is a supernatural process, right? Um,
Great plug.
yeah, I mean, we talk about giving plants superpowers, right? Um, you're giving the plant specifically the nutrients that it needs in the environment that it
Mhm.
needs to grow specifically the outcome that you're desiring. So, in our case, this doesn't require any genetic engineering. There are people that do genetic engineering at the cellular level and then grow those full plants out again. But in this case, this is a naturally sourced plant that we've just coaxed through various stages of its developmental cycle again. And so I guess to get to the heart of your question, when you're growing seeds, the question is, well, why can't you just take a natural seed and plant it in the ground? And really, there's a dramatic lack of seed for many, many different use cases. So, for example, the U.S. Forest Service can only meet about 6% of its annual restoration goals because of lack of seed supply. So that's like a conservation example where we just need way more seeds. But then also,
I want to tease it out for a second though. I think like this is a part where I'm super blind. In my mind, like when you consider a variety of seeds, like you open up a lemon, for instance, there's many
yeah,
seeds. Oak tree has many acorns or whatever their seeds are. Like I find it hard to fathom not being close to this, as close as you are. The scarcity of seeds. I'm curious
yeah.
more about that problem.
Well, there's many different layers to this. I think the first is that even if you have the seed, the germination rate is not always high. So there are some species where if you had, you know, 10 seeds, none of them would take. There are some
Got it.
grass species that have less than 1% germination rates. And so the quantity of seed that you need is just substantial. Um,
Okay.
and then when you think about, well, let's just take restoration as an example, because I think it's easy to wrap your mind around. So you're the Forest Service, and you need to go collect seed to replant an area of the U.S. West. Um, what you would do is you would go create a human operation of people to go source those seeds from nature, usually in a very remote area. Um, and then you would collect them, you would bring them back, you would, you know, prepare them for planting in a nursery. But there are a few failure modes along the way. One is, can you find the staff to go out into remote parts of the world to do this? Two, are those people going to be there when those trees happen to be shedding seeds? I mean, some of these trees don't shed seeds until, like, many, many decades into their maturation cycle. And so it's kind of a
Got
moment
it.
in time you have to be aware of to go find. Um, those are called mast events in some species. Um, and so there's a timing, there's a labor, there's a technical and a germination barrier to being able to be successful in this endeavor. What's nice about fabricated seed is you might have one seed, or you might, in the case of restoration, let's say you have 10 viable seeds. You could plant those 10 seeds and get 10 trees, maybe, if you had 100% germination rate. But in fabricated seed, from one seed alone, we could create hundreds or thousands of different embryos.
Wow.
And so you're, 10 or 100xing your capabilities. And so you're helping fight this germination barrier as well.
Is there like with the germination rate being lower, is there maybe like a aspect of natural selection type of thing in there where some seeds shouldn't have germinated? And then when you are engineering this, how do you preserve nature taking its course like that? Or does every seed come out like very uniformly? Or what is the variance, and how does that mentality impact what you do as well?
The way I think about it today is that the forces that are working against plant populations, um, they accelerate their demise much faster than a natural course with no human intervention would ever challenge a species on. And so plants are facing this, like, incredible threat, whether it's a pest and pathogen introduced by a human in the wild, or whether it's climate change or other human derived factors. Um, and so we are basically just giving plants a fighting chance to go through this sort of natural selection process again. So at some point it's about just survival, period, and then it's about thriving. And so we need a thriving biodiverse ecosystem in order for natural selection to take its course.
So the idea is like, well, we won't necessarily worry on the micro of these seeds for this culture, because by introducing this culture back into this ecosystem, we preserve the ecosystem in 1,000 different ways that are fueling like the health of the ecosystem broadly. And we have to take care of that first, and then we'll be like refining how we do these little details as we do those types of things.
Yeah, essentially, like what we're doing is a very fancy biotech enabled copy and paste, right? So you might have a biodiverse sampling of trees from a specific acreage that you're trying to make sure survive. And the best tool we have in our toolbox today is to make sure many copies of those trees exist. When you reintroduce many copies of the same or similar genetic material, they're going to continue to interbreed. And um, the general consensus here and with many of our supporters is that um, so long as you're not introducing genetically modified individuals into natural ecosystems, where you don't know the outcome might be, um, nature is going to take a similar path than it might have otherwise without sort of the human caused pressures on that ecosystem.
That's
Yeah.
an interesting take. And I think like a lot of people that will wind up viewing this are going to be very new to a lot of the science. Can you explain in layman terms the difference between what you're doing and genetically modified? I think I'm grasping the concept, but I want to
Yeah,
be like plain for our audience as well.
certainly. Yeah. I mean, so plain and simple. I mean, I'm sure you have people that listen to this pod that are gardeners, right? Um, and so let me just draw a picture or give you an analogy. You might take a cutting of a plant that you want to replicate. Let's call it a tomato plant. You would take a cutting of the vine and you might graft it with another stem, or you might plant it into soil, and uh, it being exposed to the dark, wet, and nutrient-rich environment of the soil would coax that plant to grow roots. And then once it has roots, it can feed itself off the nutrients in the soil and become a full plant again. That is exactly the process that we're following at the cellular level. And so when you think about genetic modification, there's an additional step added to that process, usually at the cellular level. Um, some of your audience might be familiar with CRISPR and sort of gene editing techniques. Once you get
Yeah.
cells into the lab and into this state, there's nothing stopping you from doing CRISPR or gene editing on that cluster of cells. We just don't in most cases. So really, we're a process of scaling or propagating these plants at the cellular level to the biggest possible outcome.
Yeah,
That's very impressive.
that's a really great explanation. I would say like the ethos of both the podcast, myself personally, and I would say much of the audience is that we want to do what is in line with nature, natural law, what is the truth, what is right, what is objectively good.
Yep.
And that's why a lot of people will be frowning upon genetic modified
Sure.
much of anything. But I think where I love this is, even if you were to genetically modify something, if I'm looking at it like you genetically modified something that went into building like a home or a structure or
Yeah.
something I was going to use, I mean, what's natural about that in the first place per se? It's manufactured, right?
Yeah.
And so if it's not going in my body, it's not, going into an ecosystem that could harm the ecosystem in some way, then it's not here nor there. It's not a harmful in any way. And so I think everything you're doing, it's maybe on that line of like where naturally you're using similar words and through lines that people may have a discomfort in when they think like that,
Yeah.
but you're doing it in such a beautiful way that's for such a good, like you've towed that line where I think it truly should be bipartisan what you're doing. It's just
Yeah.
good, it's meant for good, and it's producing good outcomes.
Absolutely. I mean, um, even in the case where genetic modification is used. So I'll give you an example. We just announced a partnership with a company called Silva Bio. They are,
Congratulations.
thank you. Yeah, they're working to de-extinct the American chestnut. Are you guys familiar with the American chestnut blight, or should I give a
No,
little?
please have at
Even
it.
if we are, I know people listening are not.
I say
So
that
let's
jokingly.
talk about the American chestnut.
I say that jokingly, but the American chestnut is an American icon, right? Some people called it the perfect tree. Um, there's thousands of U.S. street names named after the chestnut. Over the holiday season, you'll hear songs like "Chestnuts Roasting on an Open Fire." It's an American.
4th of July, Joey
There you
Chestnut,
go. Yeah,
big hot dog eater.
we have our most competitive eater. Some would say the LeBron James of eating, named after the chestnut. Um, so chestnuts are an iconic species. Unfortunately, about 100 years ago, there was a chestnut species brought in from Asia that brought along with it a fungal disease. And this specific fungus thrived on our American chestnuts, which didn't have the capabilities to fight off the fungus. And so essentially, the American chestnuts have been functionally extinct for over 80 years, almost 100 years. So they used to make up a third of Eastern American forest. And today, you might come across one that has survived into adulthood. And even if it's surviving, it's not reaching the stage of maturation where it can produce seed again and create offspring. And so there's been a number of research groups over the past 30 years that have been trying to find different ways to introduce the capability for the American chestnut to fight off this fungus. Some of them have been through natural breeding. So American chestnuts that have some sort of natural resistance and then trying to bulk a population from there. Some have interbred with other chestnut varieties, including some of the Asian chestnuts that have this natural firepower against the fungus. But the one that's really interesting is researchers at SUNY ESF in upstate New York recognize that there's a feature of the wheat plant called OXO that helps fight this fungal disease. And when introduced into the chestnut through genetic modification, the chestnuts have the firepower to fight back against this disease. And so, this is a situation where without genetic modification, you might never have a chestnut forest again. And so there's a lot of interest and a lot of dialogue today, even among restoration conservation people who, it's worth noting, are some of the loudest detractors from genetic modification. Even those people are thinking that this could be a viable solution for a biodiverse ecosystem again. And so it's just worth noting that in the early days of genetic modification, before we knew what we were really editing and what we were really doing, totally fair to have your criticisms. But and I'm certainly not a proponent of mass genetic modification, but it's a tool, and it's a tool that can be used for good. You just have to find the right place to use it.
Yeah, it's a fantastic anecdote there, because it's almost one of those things where you come back to the meaning, how you evaluate, and how you use values to create decision making for something like this. Because like most tools that can be used for bad or for good, it's maybe a segue back to, as humans, we have that decision making capability. We trust other humans who align with that. And in the age of information, like we said, where so much is blasted at you, you kind of stop thinking about that. You let maybe the systems and forces and people of authority to decide these things for good or for bad, and we just don't think about them.
Yeah.
But with more people taking an interest, thinking about these things, and having voices in these matters, then we kind of triangulate what actually is good, what is bad.
Yeah.
And I think that's what we lose sometimes with the age of information is people just don't have time, energy, bandwidth, focus. No one cares. No one thinks. And I think that's, to me, what we're trying to do with Built Human is just revisit, think, introduce topics, remind people that they're not robots. They should get off autopilot. And these are all thoughts that I resonate with a lot. So I really appreciate that anecdote, especially the chestnut. Who would have thought,
Who would have thought it? Yeah.
I think the important thing here that I'm kind of taking away from both of you actually is it's not enough to focus on the result, but to focus on the result with the consequences and understand what the consequences are. Right. And how they take impact. Alex, you just gave us a great anecdote, but even if we talk about introducing like seed oils into the food system as a way of making processing and development of food accessibility much easier and or cheaper, but without talking about the consequence of what that means on people, that's important, right? When we talk about technology, and one of the previous episodes, we talked about doom scrolling and algorithms.
Like doom scrolling and social media can hijack your brain or parts of your brain, because as we evolved as humans, like we didn't evolve with things like that. And so putting all that in front of us kind of hijacks the brain a little bit.
Right. And how the result is a much more tailored product where people see a lot more topics that they're interested in, but then the consequence is doom scrolling and spending hours disconnected from reality, right? So the process isn't just working towards a result or a solution, it's working towards a result and a solution with little to no consequence, or at least mitigating the consequence.
Such a good example. Like the algorithm kept us on the platform, therefore it was a good algorithm, but should we have stayed on the platform?
Right.
Is that good for us? Yeah, that's a really great way to
certainly, we could spend an hour talking about incentive structures, right? I think that's my biggest gripe with the age of information or AI or, social media, even in a time past, is you've got a handful of people that are determining what the incentive structure should be. And then that drives decision-making and downward behavior. And so it's certainly opens the door for a conversation as to who else should be in the room when these decisions are made. And definitely calls for some critical thinking on the individual level about how you spend your time and your effort and your resources.
I think that's kind of our counterculture ethos a little bit here too. It's like, who, at least if we're not going to be heard in the decision making, like let's have the ability to make decisions for ourselves on a micro level. And a lot of people, I think another good example of this that I always go back to is fraudulent, is the right word, fraudulent marketing around a lot of health and wellness. It's like you can get away with so much when it comes to marketing, and people who, similarly, the people who don't know about the chestnut, they don't understand the value or the premise behind some of the decisions that have led to maybe GMOs. They don't understand any of the things you just referenced, Marshy. And then finally, they don't understand the things that impact health and wellness, or the things that the fraudulent marketing would have told them is good for them. They just don't think about it. And it's just like the whole age of information thing, where you got to make quick decisions. You're blasted with information. You trust what you're being told at face value. The marketing says this is good for you, and in reality, it's terrible for you. And it's shiny. It's a box. They engineered it to make you buy it. But people who are on autopilot, what chance do they have, honestly? Like, it's the people who aren't, who the standard of ethics just needs to be raised across all of these things, because unless everyone's going to wake up and think about these things, and they're not, right? You have to care for your fellow human.
Yeah.
You have to, or they're going to get hurt by all these things. Doesn't matter if you're awake, they're not, they're on autopilot, and we're just harming everyone. It's terrible.
Yeah. I need to take a moment to call out that fraudulent marketing, because it's so topical right now. And I'm looking at you, Boulder, and I'm looking at you, Siete. I'm looking at you, any food brand that has used avocado oil within their their food and then just cut all of it with seed oils to the point where it's just not beneficial and you're trying to brand it as healthy. And then all of a sudden, here we are just backtracking. Topical, relevant. Obviously, that study, I think it came out of UC Davis, it was a big one across X this week. So I needed to take a moment to plug that because it's completely within our ethos to call out. Regardless, I do want to continue this conversation, Alex, and ask you a question. What is next for Foray? What does the future look like? I think you've mentioned many different technologies as part of this too.
Yeah.
You mentioned ML and AI earlier. To me, I can't grasp how that plays a role within in your work, right?
Yeah.
So what's next on the horizon, especially with this new realm of technology that's emerging so quickly?
It's funny because when I talk about sort of AI and ML as it relates to plants, people think that I'm just sort of BSing. They're like, "Oh, like everyone's got to pitch an AI and ML solution."
Easy to write a check for.
Yeah, yeah. Well, talk to anyone that wants to write us a check right now. But the the interesting thing about this like plant science, and I referenced earlier that this is an 80-year-old technology of using cell and tissue to direct them to become various product outcomes. What's new now is that we have a better understanding of the parameters that control that growth, but we don't always know which lever to pull and which toggle to toggle, or how much of one thing we should give it. It's essentially the recipe to go from cell to something else. Just if you were to look at the 30 to 50 different variables that go into, going from biopsy to callus culture, assuming that those were, you know, black and white decisions, like you had a one or a two, a binary decision, in other words, that would lead to about 17 billion different combinations and experiments to run, which
That's
no
insane.
scientist in a human lifetime will be able to run. We are bound by the speed of biology. Um, and so AI is really, really good, specifically machine learning, is really good at recognizing trends and what is working and what is not, and making recommendations for what might work based on what has been successful or unsuccessful in the past. And so since the beginning of the company back in 2022, before the big LLM, ChatGPT, Claude moment that we are living through today, we had been creating the world's largest data set on in vitro plants, so plants grown in labs. And over the past year and a half, really 2 years almost, we've been deploying that data set to do really interesting things. So predictive design of experiment, coming up with the right media recipe to go from cell to desired end state. And we now offer those insights through a software platform called Pando, which, as a tangent, is named after the world's largest organism. I don't know if you all know, but the world's largest organism is actually a tree in Utah. If you were to look at it from space, it would look like a forest of trees, but it's all interconnected by the same root system. So it's a nice metaphor for being able to take these siloed knowledge bases from academic labs or from other industries in the plant science world and apply it to growing things from the cell up in a predictive and successful way. And so our team is about 50% biology, 50% software, AI, machine learning. And it just goes to show you that this company might not exist if not for machine learning and AI. The industry average success rate from going from cell to something else is about 30% today. Our team has about a 90% success rate. So 3x
Wow.
better and 2.5 times faster. So less trial and error effort to get to a desired outcome.
Who else is in this space competing against you? That's incredible results.
There are plenty of companies that are doing agriculture, specialty agriculture, bioengineering with plant cells, even biomanufacturing. There are companies that create cacao, cotton, a number of things. But and even in the fabricated seed space, there have been companies that have tried to grow superior trees for lumber production using this fabricated seed process. But I think what truly differentiates Foray is that we're building the full platform for people to utilize. And so we know that, I mean, to the statistic I gave you earlier, if 50% of the global economy, $44 trillion of GDP, are underpinned by plants, is it would it be fair to say that one company is going to occupy that entire market? I don't think so. I think
Yeah.
the idea is to build infrastructure to be able to solve this big global challenge of meeting future human demand for plant products. And so we're doing that through, as I mentioned, a series of innovations, the software, and then, of course, bioproduction.
And then to focus on you, Alex, as well. You were not a part of the founding team on Foray. Matter of fact, you worked with them when you worked at the
Yeah.
engine. Why, for you, was this a personal mission that you felt so passionate about that you needed to come on board and have the impact that you've had? You obviously care a lot about it.
Yeah. Well, I can step back and give a little bit of a story. So, I mean, you shared in the intro that we all met living in E Tower at Babson, and um, I think there are a lot of people that start companies because they want to be their own boss or they want to call themselves a CEO, and I don't mean that in a demeaning way. I mean, like, that's just to the point of incentive structures. That's maybe the incentive structure they exist within, or
Right.
that's what they want to do, and there's no shame in that. For me, and I think this gets to our Babson education, we talk about entrepreneurial thought and action, like being able to identify a problem and solve it using entrepreneurship. I believe that you can take that same framework and use it to solve some of the world's biggest challenges. And it doesn't have to be just because it feels good to do something good. It can also make you a lot of money. And so, why, if you think of a decision matrix, why would I not spend my career trying to solve the world's biggest problems and also trying to make a lot of money in the process of doing it, um, and instead do things for vanity's sake? And so that's why my career has drifted in this direction. You mentioned the engine. I worked at the engine, which is MIT's venture fund and accelerator. I was there for 4 years. My primary job was helping PhDs and postdocs start companies based on their research. So I ran the largest accelerator program called Blueprint, helping people around the country, around the world, do that. And I met Ashley, as I mentioned, the founder and CEO of Foray, as a part of this program back in 2021, and stayed close with her and supported her, on the engine side as she was starting the company. And I joined just over 2 years ago now. But to answer your question directly, I think there are really um, a few reasons why this company and why now. Um, when you think about the impact that you want to leave behind, um, getting back to this idea that human health is only as sustainable as our plant system health, um,
Mhm.
there's a lack of interest and a lack of talent today focusing on this intersection of plants. Part of that is a marketing and branding issue, as I mentioned earlier. When people think plants, they think green, Um,
Yeah.
but I'm here as a non-technical person, non-plant scientist, trying to spread the news that we all depend on plants, and so we should be investing time in making sure that these continue to
Yeah.
exist in a way that helps human life flourish. Um, and
Yeah.
then second, I think there are a lot of companies that are spun out of academia or spun out of national labs, which are looking to that our technology is looking for a problem to solve. And I felt when I first saw Foray that this was, you know, a body of research that had many, many problems to solve right off the bat. And if you could just execute your way to solving a few of those, you might buy yourself the opportunity to solve others too. And that felt like a compelling way to spend my early career.
That's, I think, something that maybe unites the three of us, and we've been almost lifelong friends at this point since we're getting older,
Oh, please,
though we
no.
met in college. The it's not enough to just have impact in terms of like checking the boxes that I think would excite us. If it was, then we could work at a nonprofit. I think we want to have big lives. We want to solve big problems. you can and will make money for solving bigger problems. But if you were just making money and just solving problems and you're having no impact, well, then you also wouldn't feel right, or you'd get burnt out and you'd give up and quit and you'd say, why am I doing this? So it's, but it's been a long journey, and it's so great to see how you've deployed it and how you've come along with this. And I'm proud of you. This is awesome.
Thank you.
It's so good to see.
Me too. And this has been a ton of fun, Alex. And honestly, it's such an honor to have a circle of friends like you guys, where we can turn on the mic and the camera and just say, like, let's talk about it, because more people need to hear the conversations that we have behind closed doors. Mind you, they're a little bit different behind closed doors, but I think like the impact and power that we have on our circle is admirable. So these conversations I really cherish.
Yeah.
It's been a lot of fun.
And we're just getting started, guys. I mean, I know we're old, but we're still young. Don't forget it. And it's been great to build alongside you guys. And, you know, when we have our moments to reunite amongst our very engaged lives, it's always a pleasure talking to you all.
That's a nice way of saying Alex lets me stay at his place sometime.
You're always
as does John, but hey,
you've been with him, you've been with me. I've been with you. You now have the house that I can crash at.
That's
so
true.
Everything's easy.
You guys are welcome.
Everything's easy. Cool. Well, I do want to wrap up with one small anecdote, because sometimes we like to finish with updates, things that we're trying, things that are causing an impact. And I've been wanting to talk about this for like a month and a half. Well, probably a month. But Andrew, you got me the higher dose red light shower filter for my wedding off the registry. First of all, thank you. I still need to write you a formal thank you. I'll be writing you a formal thank you, obviously. But we finally installed that thing. I don't know. I know exactly how to describe it, but it is by far like one of the best investments we've had in the house. The moment I took my first shower underneath it, like the water is softer. My skin feels, I don't know. That's a weird thing to say. The water is softer.
Yep.
But my skin feels so much better, like waking up, and then like even if I'm taking a shower at night, it has changed my life. So I haven't said that to you behind closed doors, which usually I would, but would recommend anyone get a red light UV shower filter. It is now my favorite thing, and when I have a house eventually with more than one shower, I will be buying a second one. And I never thought like, oh, you need to invest in recurring shower filter subscription. No, I will be investing in a recurring shower filter subscription to make sure I have.
You look at you, you're glowing.
Yeah.
It must be working.
It's the red.
It's beautiful.
The red undertones, if some might say. But question for you there, John. Is it filtering the water, or is it filling the shower with red light?
Both.
Okay.
Both. So it has an attached red light ring almost that goes like right around the shower. You can take it off, and honestly, I can just put it in my desk and just have red light on me the whole time. Obviously, it's not recommended unless you're wearing these special glasses that came with it. You're going to be looking at it. But you have the red light UV light on you while you're taking a shower. You can do 5, 10, 15-minute therapy sessions, and then it is filtered. Like the water feels so much different from the filtration, the way they filter it. And then obviously the UV has helped a ton as well.
Yeah. I'm going to have to come over to your house and take a shower and try it out.
Next time we get Chewy over.
Yeah.
For those listening at home, is Alex's gorgeous, clumsy golden doodle.
Yeah. He's a funny boy.
We watch him sometimes. It's a great time.
I just got my first shower filter like every 6 months or something. I have to change it. And I was just thinking to myself, like the last week before it came, this water feels a little slimy. It's like, it's not how it was when I first got it. And then I changed the filter, felt right like it was new again. And you can really feel the difference. I don't know. Yeah, I mean, the red light is fantastic, but even just the filtering, any shower filtering, like bathing in that water, with or without the filter, oh my gosh, you can feel it immediately, you know?
I gotta give it a try.
Yeah.
You guys are like an ad read for this red light. I gotta figure it out.
They're not even on the animalbase.com shop yet. So it's
That's
like, come on, higher dose. Like, come on.
Yeah.
Come on.
I was going to say, how about we just blur the brand name, send it to them, be like, list
Yeah.
on animalbase.com or sponsor us. One of
Yeah,
the
we'll
two.
unlock
We have
the
glowing
redaction
reviews,
if
literally.
you put it on the website.
Yeah.
With all
Exactly.
the free marketing we're going to give, you know?
You know what's funny is they've commented on our stuff too. They've commented on our posts and they've like liked our posts. If we have any that are centered around red light therapy, but I can't get them to list. They're just
It's
very
like
exclusive.
it makes me mad, but I still love them because
I
I
know.
love the product. So then it's like, just come on, guys. Come on.
I know.
Come on.
Well, amazing. Thank you guys so much. It's been an incredible conversation. This is Built Human, and this has been a conversation with Alex Grant, COO at Foray Bioscience. Alex, where can our listeners find you and find Foray on social platforms?
You can find us at foraybio.com, or you can follow Ashley and I on LinkedIn. We post all sorts of fun content from the lab, so follow along.
Amazing. Awesome. I'm looking forward to hearing all of it. Awesome, guys.
Thanks, guys.
Really
Thank
appreciate
you.
the conversation.